We're going to start enhancing our GraphQL server by refactoring our code for better organization. I've put a link in the video description to our GitHub repository where you can follow along with the code changes. This approach of organizing code into modules will make our server more maintainable and scalable. As our project grows, it becomes crucial to manage changes and additions efficiently. First, in the root of our project, create a new folder named GraphQL. This folder will be dedicated to all things related to our GraphQL schema, like our type definitions and resolvers. Keeping these elements in a separate folder is a best practice for maintaining a clean and logical project structure. Let's proceed to create our typedefs.ts file inside the GraphQL folder. This file will be pivotal for defining our GraphQL schema, including the types of queries and mutations we can perform. In the GraphQL folder, create a file named typedefs.ts. We'll start by setting up our GraphQL schema in this file. First, we need to import GQL from the GraphQL tag package. This is a critical step as GQL is used for writing GraphQL queries and mutations using template literals. I'm now defining a simple query named hello that will return a string. This query serves as a basic example of how we can fetch data from our server. Additionally, we'll add a greet mutation. Mutations are used for creating, modifying, or deleting data. Our greet mutation will take a name as input and return a custom greeting message. Feel free to pause the video to copy the code. It's important to understand that these type definitions form the backbone of our GraphQL API's capabilities. Once you've copied the code, make sure to save the file. Next, we'll set up our resolvers.ts file, which is just as crucial as our type definitions. Resolvers are the functions that provide the instructions for turning a GraphQL operation into data. They're where we define how to fetch or change the data that the queries and mutations correspond to. In the GraphQL folder, create a new file and name it resolvers.ts. This is where we'll write the logic for our GraphQL server's responses. Start by defining a resolver for our hello query. We'll write a simple function that returns a greeting. This function demonstrates how resolvers fetch or compute the data for a query. Next, let's add a resolver for the greet mutation. This function will accept a name as an argument and return a personalized greeting. It's an example of how resolvers can not only fetch, but also manipulate data based on the query or mutation. After defining these resolvers, we export them from the resolvers.es file. Just like with typedefs.ts, exporting makes these resolvers available to be imported into our main server file, index.ts. Remember, the structure and names of your resolvers should match those in your type definitions for them to work correctly. Feel free to pause the video here to copy the resolver functions from your screen. Properly setting up these resolvers is key to ensuring that your GraphQL server responds as expected. Let's update our index.ts file to import typedefs and resolvers. This refactoring makes our main server file more organized and easier to manage. Now that we've refactored our code, it's crucial to test everything to ensure it's working correctly. We'll go through how to start the server and test our GraphQL schema in the GraphQL playground. First, let's start our project. Open the terminal in Visual Studio Code and run the command npm start. This will compile our TypeScript code and launch the server. Keep an eye on the terminal for any startup messages or errors. Once the server is up and running, you'll see a URL in the terminal, typically something like http localhost 4000. This is where our GraphQL playground is hosted. Click on this URL to open the playground in your web browser. GraphQL Playground is a powerful tool for testing and exploring your GraphQL server. In the GraphQL Playground, let's test the functionality we've created. Write and execute a query using the hello query we defined. Then try out the greeting mutation by passing a name. You should see the responses as defined in our resolvers. This step is essential to verify that our refactoring process has been successful and that our GraphQL server is responding as expected. We've reached the end of this tutorial, and I want to extend a huge thank you to all of you for joining me. Today, we successfully refactored our GraphQL server, making our code more organized and scalable. I hope you found these steps both interesting and beneficial for your projects. The code from today's session is available in the GitHub repository linked in the video description, so you can easily review and try it out at your own pace. If you have any questions or thoughts, or if there's something specific you'd like to share, please drop a comment below. Your feedback is not just welcome, it's invaluable. It helps me understand what you need and guides the content of future tutorials. Speaking of future content, in our next video, we'll dive into integrating MongoDB with our GraphQL server. So, if you haven't already, make sure to subscribe and hit the bell icon to get notified when that video is up. Your support means a lot and helps this channel grow. Thank you again for watching.